In this lesson, we'll multiply numbers in scientific notation. To start, I want to review some problems to see what we remember. Our first problem is 10 to the 4th power multiplied by 10 to the 5th power. Well, we have to remember our rule for multiplying numbers with exponents is that we keep that same base and we add the exponents. So our problem really is 10 to the power of 4 plus 5. When we add that together, our final answer is 10 to the 9th power. Our next problem is 2 times 6x times 4 times 3x. What we have to remember when we're doing this problem is that we could only combine like terms. This 2 is not the same as the 6x because the 6x has an x with it. So the 6x can only be combined with the 3x because they have that same variable. And the 2 and the 4 can be combined together as like terms as well. So we're going to multiply only like terms. So I'm going to get 2 times 4 is 8, and 6x times 3x is 18x. These are being multiplied, so our answer is going to be multiplied as well. And this will be our final answer, 8 times 18x. So let's see how we'd use these two concepts to multiply numbers in scientific notation. Okay, our first problem. 2.3 times 10 to the 7th power multiplied by 4.1 times 10 to the 6th power. So we're going to do that same thing where we collect like terms. We're going to get the coefficients together because those are both just decimals. And we're going to put the base 10s together because they have the same base. I know when I'm multiplying coefficients, I just multiply that out. I do that work on the side and I get 9.43, 9 and 43 hundredths. I'm going to multiply that by this base collection. So when I multiply 10 to the 7th power multiplied by 10 to the 6th power, I have to add those exponents. So my answer is going to be 10 to the 13th power. I have to double check my coefficient to see that it's a number between 1 and 10. This is a number between 1 and 10, so I don't have to adjust my answer. Let me look at a problem where I do have to adjust my answer at the end. Okay, our second practice problem. So we're going to go to that same steps where we're going to find like terms. These coefficients are like terms, and these base 10s with exponent are like terms. When I multiply my coefficients, 6 and 3/10 and 4 and 1/10, I get 25 and 83 hundredths. When I add my exponents, my base 10 is now 10 to the 9th power. I got 9th power by going 6 plus 3 up here. When I look at my coefficient now, this is supposed to be scientific notation. This is not scientific notation yet because my coefficient is a number above 1 and 10. 25 is not a number between 1 and 10. But if I move this decimal to the left once, I'm going to get 2 and 583 hundredths. This is a number between 1 and 10. So I'm going to multiply this by my base 10, but I have to remember I moved my decimal left once. And moving that decimal left, I made the number 25 into the number 2 and some change. So this number is a lot smaller than this first coefficient. So that reminds me that I have to add 1 to the exponent. So 9 plus 1 is 10. This will be my final answer in scientific notation. This is your lesson check for this lesson. Please give the answer to this problem to receive your homework for today.